Okay, so in this problem we need to figure out which of the following are subspaces of f minus infinity to infinity. This is basically the set of all real valued functions that are defined at each x in the interval negative infinity to infinity, basically at each real number. So we have our first set, which we need to check, is the set of all functions that vanish at 0. So this is a vector space because first of all the 0 function belongs to W1, and suppose f and g are two functions in W1, that means f of 0 equals 0 and g of 0 equals 0. So f plus g of 0 equals f of 0 plus g of 0, which is 0. So the sum f plus g is also in W1, and for any scalar alpha, alpha times f of 0 is alpha times f of 0, which is alpha times 0, which is 0. So that means 0 alpha times f also vanishes at 0, so alpha times f is also an element of W1. So W1 is closed with respect to both addition and scalar multiplication. So this is a subspace of f negative infinity to infinity. Let's check for the second one. We call this set W2, and this is the set of all functions that take value 1 at the point 0. So this is very easy and immediate to notice that this is not a vector subspace because the 0 function that is 0 defined as g of x equals 0 for every x, this does not belong to W2. So this is not a vector subspace. It is also very easy to see that if f and g are in W2, so f plus g takes the value 2 at 0 and not 1. So the sum is also not inside the space W2, and similarly not all scalar multiples of elements of W2 are in W2. So this basically does not satisfy any property of subspace. Let's move ahead with the third one. We call this W3. This is the space, the set of all functions such that f of negative of x equals f of x. These are called even functions. So this is also a vector subspace because of course the 0 function belongs to W3, and if f and g belong to W3, this would mean that f plus g of negative of x equals f of negative of x plus g of negative of x equals f of x plus g of x equals f plus g of x for every x in the real line, on the real line. So f plus g belongs to W3. Similarly, for any scalar alpha, alpha times f of negative of x equals alpha times f of negative of x, which is alpha times f of x, which is alpha f of x. So alpha f belongs to W3. So this is a vector subspace. And finally, the last one is W4, and this consists of f such that f is a polynomial of degree 2. Again, this is not a subspace because 0 does not belong to W4 because it is a polynomial of degree 0 and not 2. So